Today we're going to talk about where is the intersection between children's social emotional welfare and learning mathematics, and how the two are related. And we're going to do a series of activities where you develop specific skills for working with your students to help them build the resiliency that they're going to need to be successful in mathematics, and the skills that they're going to need to persist in mathematics, and frankly, the attitudes that are going to make them, we hope, like mathematics and want to persist in it. So I want to start the class out by asking you to look at a piece of data. It's right out of our data group. And I want you to take a moment and talk in your groups. I'm going to tell you this is proficiency scores on the CST. You have grade level and the percent proficient. And would you in your groups for a moment just practice that art of interpretation that was so well taught to us with the data group? In your groups, talk about what is this graph telling you about what's happening to children as they pass through the grade levels.
I mostly noticed like the decline instead of the incline.
Yeah, there's definitely a peak in 4th grade.
So that's like that rapid decline from 4th grade to about, what, 6th grade or 7th grade? It's like a rapid decline.
Oh, it's even more.
And then it tapers off.
They start algebra.
Yeah.
Let me bring you back. Graphs always have a story to tell. What's the story? Thoughts? What's the story? What's this graph telling us about what's going on for children in mathematics? Yeah. I want to say when we talk about why would it be important to teach social and emotional learning skills, I'm talking about specific domains of social and emotional skills that will help children in life and also in mathematics. Self-awareness and regulation, that we can work ourselves through a task that is uncertain. Social skills, that we can communicate with each other, that we can build relationships, that we listen to one another, that we can trust one another, that we can form a classroom community, and even decision-making intersects with mathematical problem solving. What happens if I take a path and it doesn't work? I need to examine my strategies and take a different path. These social emotional learning skills are embedded in how children will do math. So let's take a look at how one set of them plays out. We're going to start with emotional awareness and regulation. And I'm going to show you a problem, and I'm going to read it out loud to you because sometimes it's a little hard to see the screen. And rather than asking you to do it, I want to ask you, how does this problem make you feel? Okay, what's your emotional reaction to it? So here's the problem. And it starts out saying multi-step problem, which I want to say are words that strike terror into the heart of any 6th graders. Multi-step problem. The density of a substance is the ratio of its mass to its volume, written as a unit rate. Calculate. A 500 cubic centimeter sample of seawater has a mass of 514 grams. Find its density. A 300 cubic centimeter sample of an iceberg has a mass of 267 grams. Find its density. Compare. Which is denser, seawater or an iceberg? Explain why your answer is reasonable. I want you to talk in your groups for a minute, and really I just want you to look inside yourself and be aware of what emotions are you feeling right now. If I said, go do it, guys.
We started with anxiety, and that's why we got led into how we would make it less, instead of all this vocab and so much text and numbers thrown at them, you know.
So this is good. You just can't stop being teachers.
Yeah.
Well, I was saying, like, as a student, like, when I was in 6th grade, I just remember there was a very strong, like, science when I was in 6th grade, and I would have looked at the picture and said, well, obviously the iceberg's less dense because it's floating in the seawater, so I wouldn't even have tried to calculate anything. That would have been my rationale, and
Which would have been very smart.
She would have found a way to
it doesn't say show your work, so
We'll get to that later. Yeah, go for it.
First looking at this, scary. And the first thing we talked about in our group was our second language learners.
Absolutely.
Just because density, volume, cubic centimeter, those are big words, and I don't think 6th graders would really know what that means. My 6th graders wouldn't know what that means right now.
I'm very systematic in my approach. I would go from the very beginning, what is the first thing it's asking me to do, and just focus on that. Before even reading farther down, I would focus on one thing at a time, making my way down that huge word problem. And yeah, so
You know, a lot, I think what you're saying too, a lot of kids would just look at it all and just start trying to figure it all out as one big problem and not breaking it up, because that's what they think they have to do. They think they have to look at the bottom of the question and what is it asking me? And they'll completely lose themselves.
Yeah, exactly. Lose themselves throughout the whole process. But when really the question usually builds on each other.
I actually liked what Steve said when he looked at it and he said challenge accepted. And I kind of like teaching that to students to look at it and say, okay, challenge accepted, and then kind of similar to just break it down. How do you eat an elephant bite by bite? So just one step at a time, but to have more of a positive attitude of like, yeah, this is challenging, challenge accepted. I'm going to go ahead and take it.
I love that. I love the idea, and I don't think it's going to come instantly. I actually think we have to teach children it's safe enough to say challenge accepted, which means challenge accepted, I might be wrong the first couple of times. I might have to change my strategy midway, but challenge accepted.